Any doubts, you can stop whenever and you can ask doubts. Okay, there's no issue. So we'll be mostly dealing with basic stuff. So I guess there will be not much doubt in it. So I'll share the PPT now. So is the PPT visible?
Yes.
Okay. So like let's go. Hmm. So in today's session, we'll be mostly dealing with the basic definitions and what are the components we are dealing in our lab. So we'll be going through the definition of electronics, resistors, capacitors, inductors, transistors, and switches, relays, limit switches, potentiometer, and motor drivers. So this session mainly helps you to just get a basic idea of what, and mainly for non-circuit branch people. Circuit people will have a good idea of what these are, and you, during your JE times also you would have a very good resistors, capacitors, just basic things, nothing much. So what is electronics? So as we all know, electronics is the flow and control of charges and study of circuits. So electronic circuits mainly consists of resistors and capacitors, inductors, and transistors. Right. So yes, according to you, what is like electronics? Can anyone speak up or chat? Anything in the chat box? Guys, can you hear me?
Components of an electric circuit that allows current to flow, something like that, according to us electronics.
I sorry, but I can't hear you properly.
Components of electric circuits that pass current through it and give a pathway, completes it.
Okay. I guess there's some issues on my end. Okay, but could you type what you said? Is that better? Is it better? Ah, okay. Components of circuits that involve with DC supply. Ah, so not AC. What about AC things? Okay, so what about the things that we deal with AC? Does don't those things won't they come under the electronics? Yes, circuits people will be dealing their next some electronic circuits too about these AC stuffs and machines. Yeah. So can any other person say what is electronics? Right, I want this session to be a little bit interactive. So if you guys, because like the topics at the end will be a very much interactive. The last four slides, 4 to 5 slides, a bit, little bit interactive, not that much, just type something. Okay, so we'll be moving through what is a resistor and capacitor, inductor and transistor means. Yeah. So as you all know, like a resistor is a component which opposes the flow of charges in the electric circuit. And we all know BB Roy of Great Britain have a very good wife. So resistors is nothing but which opposes the flow of charges. We all know SI unit is ohm. And then what is a capacitor? So a capacitor is a device which stores and releases energy. In our lab, we'll be using not as a single component, but you'll be seeing these capacitors in most of the MCs or relays and motor drivers. Yeah. So basically, capacitor, what it does is when a potential difference is applied between 2 points, like between across the capacitor, it starts to store charge in it, and it has equal charges on either side of the plates, and it stores these charge in the form of like it has some potential across it. So it do have some certain voltage across it and releases charges according to the potential difference across the circuit. Yeah. And then yeah, what is an inductor? So an inductor is a device which resists the change in the flow of current. Let's say an inductor is present in the circuit. I wanna increase the current amplitude, but what inductor does is it opposes the increase in the opposes the change in the increase. So inductor try to reduce the current's amplitude. If I want to decrease it, it tries to increase the amplitude of the current. Basically, basically this is what an inductor does. And in your electronics, like circuits, people will be dealing with inductors and capacitors highly in your fourth semester. You will be dealing with buck converters, voltage amplifiers, not voltage amplifiers, like AC to DC things. You will be dealing with these inductors and capacitors. Yes. And then what is a transistor? So a transistor is a device which has how to say like mm, basically a transistor is a device which acts as a switch or an amplifier. So according to the regions it is in, it acts as a switch or as an amplifier. As you all know, like uh, what these are NPN and PNP. So N has N region has more electrons and P region has more holes. They have been studied during the JE days. Uh, Now we'll deal with what does an NPN transistor means. And in an NPN transistor, uh, P region will be the junction between that is the junction between two N regions. So basically, if you put it together, it's this P junction will be P will be in between the N regions. So in an NPN transistors, like basically in a transistor, you will be having three terminals: an emitter, base, and a collector. Circuits people would have been studied during this in electronic circuits one, I guess. Mm. In, in, in PNP, N will be the center between P regions. Nothing much difference between them. Yeah. So now the components that we'll be dealing in our labs. Now, the components that we will be dealing in our labs are mostly switches, relays, limit switches, motor drivers, and potentiometer. So we will be dealing in depth with motor drivers because that's very important in our lab, like because we'll be dealing with almost every projects and switches also like switches, yeah, like but not that much, but mostly we'll be dealing with microcontrollers and motor drivers. So first we'll just see through what are switches means, switches, relays, and potentiometers, and then we'll go into motor drivers. So switch, we all know what does a switch do. It completes a circuit and it breaks a circuit. So in switch is an electronic device designed to open or close an electric circuit, thereby controlling the flow of electric current. In switches also we do have many types like SPST, SPDT, DPDT, and DPST. So what does these four terms means? So SPST means it's single pole and single throw. Actually, SPST have only two terminals. So SPST just controls one circuit and either it can on or off. So that's what it means. Single pole means it controls only one circuit at a time, and single throw means either it can go up or down, which in the sense it either turns on the circuit or turn off the circuit. And SPDT, single pole and double throw. So it basically controls two outputs and with one input line. So this is the common line, like the one on the right for SPDT, the one on the right, that is the common thing. And when it is turned on, it controls one part of the circuit, and when it is turned like down, it controls the other part of the circuit. So DPST is sorry. So DPST, so it's double pole and single throw. It simultaneously controls two parts of the system. Like, yeah, so this is DPST. It when turned on, both the circuits will be completed, and these both will be both lamp and the diode will be like passing current through them. When turned off, both the circuits will be incomplete and no flow of current will be through the system. And DPDT, it's just DPDT. It's not that it looks complex, but it just controls four different circuits. When it is turned on, it controls two parts of the circuit, and when it is turned off, like turned down, it controls other two parts of the circuit. It's like it controls two separate circuits simultaneously at a time. Do you guys get it right? Do you guys have any doubt in these four? No, right? Okay, so yeah, okay, fine. So there, so after these switches, relays. So can anyone say, like, at least in the chat, what's the difference between a switch and a relay, if possible? Okay, relay is electrically controlled. Yeah, that's it. So a relay is a device. These are like electrically operated switches that use small control signal to switch a much larger load. So a control signal energizes, that's just the science behind how does a relay works. So a control signal will basically relay has a magnet. A control signal will electronics like okay, a control signal energizes an electromagnet, which helps in moving the contact so that it can either complete the circuit or stop the circuit, like break the circuit. Mm, we'll be using Arduinos to send signals to these relays. It's just we are controlling the controlling the circuit where at what time if the circuit should function or at what time the circuit should not operate using the predefined commands in Arduino code. Yeah. So this is the Arduino, like this is the relays which we normally use in our lab. This is like a single relay. In our lab, we have been having like four set of relays attached together in a common board. So we'll be controlling the ground, VCC, and signal pin to the Arduino, and we'll be controlling the left side, normally closed, common, and normally open, to the part of the circuit that we need how it should operate. So limit switches, like, do anybody know how does a limit switch work or what is it used for? Any answers? So a limit switch is an electromechanical device. Like, I'll put it simple. So like a limit switch is like it's mechanically operated, that is like used to detect the physical limit. So if some part of the circuit, let's say, touches this part, then it either completes the circuit or like breaks off the circuit. So let's say yeah. So if a machine part like so it basically has a lever or like yeah, lever that gets physically pushed when moving part reaches a certain position. So once triggered, like once the physical part touches it and this thing gets triggered, it opens or closes as the circuit, just like a regular switch. Okay. So it mostly like this limit switch, it is used in automation thing. I guess Aviboard is using limit switch. Yeah. In Aviboard, we are using limit switches. So next, potentiometer. So most of you guys know what is a potentiometer means. Like it is just a device used to vary potential difference across the circuit, nothing much. This is the potentiometer down here. Right. So next, water drivers. So this topic is like very important. So yeah, why like why a motor driver? Can anybody try to answer this question? Why a motor driver?
To control when the motor should be turned on or off.
Why not Arduino? Why specifically we need a motor driver to drive a motor?
Yeah, speed maybe to give the required power to the motor.
Ah, okay. Yeah. In chats also we do have some answers. Yeah. Arduino's 5-volt can't directly power a motor. Yeah, that's correct. It can't handle the current. So it can't handle the current. Which thing can't handle the current, Matthew? Is it the Arduino or the yeah, yes, yeah. Okay. So we use motor driver to power out the power up yeah, to basically power the motor. Why can't Arduino power the motor is the output of a Arduino board is 5 volt, but the motors we'll be dealing in our lab are around 36, something on 36 or 48 volt. So Arduino can't handle like yeah, can't power up that much quantity with its range. So we use motor driver because motor driver, yeah, basically will be powering up the motor driver also. Since but since Arduino can't handle that much voltage, we'll be using motor drivers to power up these motors. So we'll be connecting motor drivers, we'll be controlling motors using motor drivers through Arduino. Did you guys get that point? We'll be controlling motors using Arduino through motor drivers. We wait, I'll put it in the chat what I have just said. Yes, that's correct. Maybe like this, some grammatical errors may be there. Maybe this Arduino and motor driver should shift. I don't know. But you guys get what I'm trying to say, right? Got what I'm trying to say, right? So, okay. So this is the L9 3D motor driver. So this is in our lab, and we'll be using. Uh, I'll just go through these things. What is it? So you can control based on the input you're giving through Arduino, like the codes. You can either rotate a motor clockwise or anti-clockwise. Okay, so this is the table. I'll be sharing this in the group. Just go through it for once. Uh, so yes, let's say like one so this L29 3D, it can control two motors at a time. For now, I'll just say like just take one part, like just controlling one motor. So you will be giving PWM signals from Arduino, like not from Arduino, from Arduino board, you'll be giving PWM signals, and according to that, you'll be controlling the motors. So for PWM, you should connect from Arduino board to the motor driver, enable one. So that helps in PWM. So input one and input two in the sense it's just you're connecting positive and negative of the motor to input one and input two. No, from Arduino board to motor driver. According to. So if input one is high and input two is low, the motor rotates anti-clockwise and the vice versa. Low and high means clockwise. If both the digital pins are on high, the motor never rotates. As in the same case for low, like like high means 5 volt and low means 0 volt. Yeah. So next, Citron motor drivers. So Citron motor drivers deals with higher voltages. Uh, we use Citron motor drivers for uh, Arduino, most of the projects in our lab. Like we use Citron for Rigu, uh, I guess for Avibot also garbage collecting. Most of the projects in our lab will be dealing Citrons, not L29 3D. Yeah, so this is one of the Citron motor drivers used in hospital bed. Yeah, and that's from my phone. Uh, it can go through these terms like VN, motor power supply, ground, PWM for input for speed control, direction into brake, yeah, and limit. So it's the same logic as L29. If the enable pin is in high and both the outputs are same, you will not get any rotation. If the uh, enable is slow, you will never get an output. Yes, I guess that's it. So, in this session, like I have said mostly about the basic electronics like switches, relays, and those stuffs, and motor drivers. So to control like a motor driver, like no, to control a motor, we'll be using motor drivers, right? So and we also be using MCs. So next session will be mostly we'll be learning through how does an MC work and why we need an MC and some MCs we use in our lab like uh Raspberry Pi and Arduino. So the next session like Rithwik will take. So I'm just uh leaving it through Rithwik. So do you guys have any doubt? If you guys have any doubt, you can ask from motor drivers. I guess you guys don't have any doubt from the previous things. If you guys have any motor like doubts related to motor drivers, you can ask. I'll wait for some time. So, if you guys don't have any doubts, you can react with your thumbs up. Okay, one, two, three, four, five, six, seven. I need 12 more people. Eight, nine, 10 more people. 10. Okay. Yeah, I guess that's it. Ritik,
Ada.
like, you can take on from the line.
Yeah, sure.
Okay, okay, guys. Thank you.
So hi guys, I am Rithwik. I'm a third year triple student, and I will be handling the session for microcontrollers and microprocessors. So am I audible now?
Yeah, you
No.
are audible.
Yeah. Okay. So give me a minute. Is the screen visible? Hello.
As the it's written,
Okay, fine. So I will be handling the session introduction to microcontrollers and microprocessors. The main microcontrollers we'll be using in our labs are first one is Arduino. That is for a basic prototyping. If we get one idea, like we will be just taking that and flash the code to it and just check whether it is working or not. And if you want more connectivity like Bluetooth or Wi-Fi, we will be using Node MCU. The other name of Node MCU is ESP8266. I think you will be mostly familiar with Arduino and Node MCU. And the third level is ESP32. ESP32 is comparatively a little bit expensive and it is more powerful than Arduino and ESP32, like ESP8266. So that's the basic difference between these three. Then there comes microprocessors. Microprocessors, the best example for microprocessor is Raspberry Pi. Like Raspberry Pi is a single board computer. The main difference between the controller and processor is controller contains everything it wants. Like it will be having a CPU, it will be having a pins, LEDs, like everything it wants. But the microprocessor may contain only the CPU, and we'll have to add everything like the pins and all to make it work. And that's the main difference between controller and a processor. And the GPIO pins will be common for both the controllers and processors. GPIO means general purpose input output pins. Okay, and there are mainly three type of pins: digital, analog, and special functions. Digital pins. The best example I can say is Are you familiar with IR sensors? Like, can you reply in the chat? Okay. Yeah. So IR sensors output will be either high or low. If an object is placed in front of them, it will be giving high, and if it is not there, it will be giving low. So there is only two state for the output. It is either high or low. For that type of sensors, we can use digital pins. And the example for analog pins will be, are you familiar with ultrasonic sensors? Like, it will be used to measure the distance between an object in the place in front of them. So the distance will be continuously varying, right? So it requires continuous sending of data to the pins, and the distance will be multiple levels, like it will be one, two, three, etc., like that. So in that case, we will be using analog pins, and the third one is special function pins. There are many type of pins like that. The main one is PWM. PWM means pulse width modulation, and I will be discussing it later in the session. And we want to communicate between the sensors and the controllers, right? So there will be some protocols, and for each protocols, each controllers will be having specific pins. For I2C, there will be some two pins. For UART, there will be USB port, like that. So I think you all know this because the basics of microcontrollers have been familiar to you through the induction processes. But I just want to make sure that like you know the very basics, like the theory behind it, so that you won't face any trouble in the future. Okay. So this is a PWM. Like, can anybody tell what is PWM? Like, from your knowledge? Hello.
It is the number of duty cycles.
Yeah, we can define the duty ratio of the output. Like, for Arduino is an 8-bit microcontroller. So the total value will be 2 raised to 8. That is out of 256. So the values will be varying from 0 to 255. If I set the output as 255, the LED will be lighting at the full brightness. And if I put the output as 0, the LED will be off. So logically, if I put 128, that is a middle point between the 0 and 255, the LED will be at 50% brightness. So like that, I can control the duty ratio of the signal coming out of it. So that is the main advantage of PWM signals. The same thing, the same concept can be applied to the speed of the motor. You can control the motor speed using these PWM values. So if you want half the speed, you can set the duty ratio to 50 by giving 128. But in ESPs are 10-bit microcontrollers. So for 10-bit, the value will be from 0 to 1023. Okay, so like that, you can manually control the brightness of an LED or speed of an motor. And the main industry application of PWM is in power regulation. Like, AAA guys will be having a course called Power Electronics in their semester 4, and the major theory behind the PWM will be taught in that course, and you will be having a hands-on course for the to make a DC-DC converter, and that's super fun, and we'll be having it. So the main industry use for PWM is in switches. Like, you will have to switch on and switch off a switches very fastly. So you can set the PWM, the frequency of the PWM to a very large, for example, 100 kilohertz, so that you can turn on and turn off a switch like fastly in 1 second. So that's the main use of PWM switch in industry. So the other two things in controllers and processors like Raspberry Pi is interrupts and timers. Timers is basically for scheduling. Like, if an LED is on, like I can define that after 5 seconds I want it to be off. So I can, in if you are using Arduino IDE, we can call like delay 5000 in parentheses. So 5000 means 5 seconds, and in microprocessors and microcontrollers, we will be mentioning the time in the unit of milliseconds. So if I want a delay of 10 seconds, I will be writing 10,000. Okay. And the next thing is interrupts. Interrupt is basically like we'll be coding, like it's in the coding part. Like if an external event happens, like if um, if a sensor is detected, we want that LED to be lightened. Okay. So we will be programming like if like in that if loop we will be programming. So that is an interrupt. We will be having an external event and we will be coding the output of an external event. If that happens, we want a set of program to be run. Okay, that is basically interrupts. And the set of programs that is going to be executed if that event happens is called interrupt service routine. That is called ISR. And for EC guys and triple E guys, you will be having a course called microprocessors and microcontrollers, and you will be having these topics very detailed, and you will be also learning to code in assembly language too, and that is also nice. And now comes the basic communication protocols. I'm not going into so much details because there is another detailed session for sensors and communication protocols. So I am going only through the surface level of these protocols. First, I'll go to the wide protocols. The first one is UART. I think most of you guys are familiar with this because during the induction project, we'll be flashing the Arduino or ESP, right? For that, we are using USB cable, and that USB cable is the best example for UART communication. And like there's a parameter called baud rate, BAUD rate. So that is a rate at which the data is being transferred between the laptop and the board. And the most common baud rate is 9,600. And you can change if you want to increase the rate of the transferring of data. The second one is I2C. I2C is mainly for two-wire communication. Like they will be having two wire. One is for clock. The wire's name is serial clock, SCL, and the other is namely SDK, serial data. So these two are the main pins in I2C. And the fourth one is Raspberry Pi. Fourth one is mainly used in Raspberry Pi. That is called SPA. SPA is basically a complicated wiring. Like it will be having approximately 4 to 6 wires. And in market, there are some converters available to change the connection of SPI to I2C so that we can connect some sensors to that is mainly designed for Raspberry Pi. Like we can connect it to ESPs and Arduino using that two wires. Okay, so that is the main advantage of that connectors. You can just search like SPI to I2C converter. Like it is cheaply available in market about 49 rupees or something. And the main connectivity of NodeMCU and ESP32 over Arduino is Wi-Fi and Bluetooth. Okay, and Bluetooth we are not using it like as an like reliable path because like due to the distance issue we are not using in lab. Okay, the the main advantage of ESP over Arduino is their communication capabilities. So the first one is Wi-Fi modes. There are mainly two types of Wi-Fi modes. First one is station. In station mode, you can connect a device and your ESP to a common Wi-Fi, and you can control the things happening in ESP. And second one is access mode. Access mode is it is basically the ESP can host a server inside that, and you will be getting the details of the hotspot in the serial monitor while you will be flashing the code into the ESP, and you can connect it to the uh, uh, server of ESP like you connect like you just connect an hotspot. Okay, that is very simple, and I think you will be mostly using that access point. And the second one is Bluetooth, and as I said, Bluetooth will be like avoided by hours in lab because it's not reliable because of the distance issue. And the third one is ESP now. ESP now is basically developed by Expressive. Expressive is the company that manufactures ESP32 and ESP8266. So it is basically for ESP32 and ESP8266 to communicate between them. So are you familiar with ESP now? Any of you guys? Okay, I think your batchmate again, I know, like he took my project as the induction project. He used ESP now in that, so you can ask him for any details regarding. Or there are some sites in like the last slide. So if you have any doubts in setting up the things, you can refer to that site. I will be explaining that in the later part of the session. And this thing is just theory part. I don't think you will be having the application of this memory and its knowledge in our lab. Like, this is just for like the basic understanding of what happens in a controller or processor. Flash memory is the place where the code gets stored. Like it's in the name also. Like if you are flashing the like it is said that we are flashing the code to the controller. Flashing means we will be just storing the code in flash memory, and every time we will be flashing a new code, the old code will be flashed away, deleted. So that is the main advantage of flash memory. It's not permanent. The second one is SRAM. SRAM just stores the variable that is being created during the execution. Like, for example, there's a variable called LED status, and the LED status will be either on or off, right? So, during the time of execution, the LED may be on or may be off, and that value will be stored in that SRAM. And the third one is EEPROM. That means electrically erasable program memory ROM. And these are the basic memories that is mainly used in microcontrollers. And these are not for your application. This is for understanding, as I mentioned. Okay. And I think I don't have to like explain more because Raghul have said it. Like the best example for the ecosystem is a motor driver. Because we can have the sufficient power to drive a motor from our Arduino or ESP. So we will be using a motor driver, and we will be sending signals from our Arduino to motor driver, and the power that is required to drive the motor will be also connected to the motor driver. So the motor driver acts as an intermediate between the motor, the Arduino, and the power supply, and that is what is meant by an ecosystem. And you will be having different types of motor drivers. Like for DC motors, there will be one motor driver. For servos, there will be one motor driver, and etc. And there will be also another type of motors, and there is a vast field of motor drivers in the lab. You can explore when you come there. Okay. And so I have one quick question for you. What was the problems you faced during your induction process while prototyping? So can you just mention some of the issues? Hello, guys. Hello, am I audible? So give some reply in the chat. Okay, motors failed at times. So I here have some list of problems you will be facing there. So to tackle that, first you have to check the connections. Like the main mistake will be you will be defining some pin as an output, and you won't be connecting that pin to the motor. So there will be some connection issues. The second one, while to check the code is working, is in a basic code there will be lots of loops like for loops and while loops. And if you want to check whether that session of code is executed, you can just add a snippet called like something to print in the serial monitor. So we can know that like that section is being executed. Okay, that is a simple way. And if nothing works, you can check the entire thing separately. So for example, if you are having a system of 5 motors and nothing is being worked, that will be either the issue of power supply or either the issue of motor driver or the motors separately. So the last way is to test the motors individually. You will be directly connecting the motor driver and the power supply, and you will be testing each of the motors. So that is the last way to find some errors. And for some motors and LEDs or sensors, there will be some current limit and voltage limit, and that may not be specified in that module. So you can either refer to the data sheet of that thing, or if you're buying that in online, like in that website itself, there are some specifications called the maximum voltage ratings, maximum current ratings, etc. So that will be very handy while the prototyping phase to avoid some errors and faulty connections. And these are some design considerations. The first one is pull up or pull down resistors. This is for the best example is if a pin is needed to be 0, that is low, and but the pin is not connected to anywhere, you can just add a pull down resistor and connect it to ground, so that we can ensure that it is low every time. That is the use of pull up and pull down resistors. And the second thing is voltage level shifting. In microcontrollers, based on the architecture and the companies and manufacturers, there will be 5 volt and 3.3 volt at the output. So in Arduino, the most pins are outputting 3.3, I guess, and only 2 pins will be having an output of 5 volt. So if you are having a motor that wants 5 volt and you don't have the uh, sufficient pin in Arduino, that will be an issue. So you just want to check that whether the thing you want to connect works on 3.3 voltage or 5 voltage, because there was some issue in our lab. Like if you connect the 3.3 motor to the motor or some sensors to 5 volt, it may burn. So it is very important to look at the voltage ratings before connecting to a pin. So please make sure to follow that. Okay. Then the third thing is power decoupling. That is mainly to filter out the noises. Like you will be adding a capacitor um, directly at the power input, so that you can filter out the some filters coming from the source. Okay, and you can also do that to the output pin of the motor, so that uh, like there will be no shiverings for the motor. Like the motor will be operated smoothly. The fourth one is drivers that will have mentioned. Like motor drivers will be used for the smooth operation of the system. And this first one is very important. Like all of you must take care of this, because there was some issues. Like during your Origo time, there was one case where one laptop was damaged, because you will be connecting the laptop to Arduino, right, for flashing the code, and Arduino will be connected to motor driver to like for a system, and a DC source like 12 volt or 24 or even 9 volt is connected to the motor driver. So in some cases, if the motor driver is faulty, that 9 volt can be directly reach your laptop port. So like if your laptop don't have any safety features, the motherboard will be affected, and it will cost about 30,000 or 40,000. And during our induction time also, one guy had this problem, and your Origo time also one guy had this problem. So please make sure to follow this. Like this is a very important thing to look upon to. And the second one is GPIO current limits. Like the microcontrollers will be having a current limit for each of the pins. So if you are trying to connect a lots of sensors to a single pin, that each sensors will be drawing some amount of current. So the total amount of current will be exceeding the capacity of the GPIO pin. So it can't, the controller can handle that much load. So you must take care of the load you are connecting. Then the decoupling capacitors, like I have mentioned earlier. Now we are going to Raspberry Pi. So how many of you are familiar with Raspberry Pi or have used Raspberry Pi before? No one is familiar with Raspberry Pi? Okay, like can you please mention what is the main difference between Pi and Arduino, or like for what purpose did you use Raspberry Pi? Oh, okay, okay. Like here in our lab, Raspberry Pi is mainly used for projects that requires more processing power. Like I will be coming to an example. So firstly, we can move on to the main features of Raspberry Pi. It is a Linux-based OS. The OS name is Raspbian. Okay. The main advantage is in Arduino we can code only in embedded C. It's a variant of C or C++. So in Raspberry Pi, we can use whichever language we want. Okay, it's either Python, C, C++, anything you want, you can use. That is the main advantage of Raspberry Pi. And for the interfaces also, there are a lot of pins. There is an HDMI cable. You can connect directly to monitor, and there are 2 to 3 USB ports, and there you can connect Ethernet directly to it, so that you won't be like in some cases you won't be having some access to Wi-Fi, right? So you can connect directly an Ethernet cable, and these are the main advantages of Raspberry Pi, and it is much faster than our microcontrollers like Arduino, ESPs, and Node MCUs. So in our lab, like we have just completed a project called face detection system. Like it is an attendance system. So that is the framework is YOLO. Like YOLO means like it's a deep learning framework. Okay, image detection system. So we'll be registering our faces, and we will be marking the attendance. So that is a basic thing behind that. So it requires more computational power than the basic Arduino. So for that purposes, we will be using Raspberry Pi. So I have just said an example, and another is you can host web server in that, like a really powerful web server in that, and like these are the main uses of Raspberry Pi. And ROS integration is much easier. ROS means robot operating system, and that is the main framework of our Rigu. Rigu is our semi-humanoid robot. So in that cases, Raspberry Pi will be more handy. So when we use Pi versus Arduino or ESP32, like I have said, Raspberry Pi will be used in like AI projects or OpenCV projects. The best example is face detection camera. So you want to register some faces, and you want to detect the faces at some times. So it requires more storing and computational powers. And the second one is IoT dashboard. That is basically a web server. And Arduino or ESP32 will be used in cases where the idea is at the building stage. Like first, if you get an idea, you'll be directly taking an Arduino and flash some code and do it. So that is basically where Arduino plays a major role in our lab. Arduino or the Node MCU is the most accessible thing in our lab, and it is because it is very cheap, and most of the initial part of the prototyping doesn't require much computational power. So basic automation can be done in Arduino or ESP32 or Node MCU. So that is where the difference between Raspberry Pi and Arduino or ESP32 comes. So this is what I have mentioned before, Raspbian OS. So this is a Debian based OS. Like you will be dual booting the systems when you come to lab. So we'll be having an hands-on session, like explaining the basic commands of the Linux and all. So like don't worry seeing this at lots of code and scripts, like you'll be familiar, okay, with time. So the key feature is of this Raspberry OS is lightweight and optimized. Like as I said, you can optimize it with lots of languages. You can use your language as wish. So that is the main feature, and desktop tools like browser is there. Like if you install the full Raspberry OS, you will be having lots of apps like your normal PC. Like you can use a browser there, you can use camera there, everything is there. So that is the main difference between Raspberry Pi and ESP. Like Raspberry Pi is actually a computer. It's a single board computer, which is a mini computer that have much more computational power than ESP. So this is a special feature of Raspberry Pi. In products like Rigu, uh, we are using a mini PC. We are not using Raspberry Pi there because Rigu needs lots of computational power. Like we are autonomously mapping this area. We'll be navigating through them. So we are having a large number of tasks. So we are using a mini PC there. So while some exhibitions and all, you can't connect keyboard and mouse for everything you want. As a mini PC, if you want to interface, we want a keyboard or monitor. So that is not possible every time. So what we do is we'll be directly connecting the PC to a common Wi-Fi and our laptop to a common Wi-Fi, and through SSH we can access the terminal of the PC with our laptop. If both are connected to the same Wi-Fi, so that thing it's very handy while doing some projects. The best example is Rigu, and people who will be working under Rigu will be familiar with this kind of setup because you will be launching the launch files with this SSH setup. And this same thing goes for Raspberry Pi. If you don't want a display, or if you don't have an HDMI cable to connect to a monitor, you can just set up this using SSH, and you can monitor or you can execute some tasks with your laptop in Raspberry Pi. So that is a good feature in the PC area. So this is what we have learned, the MCU platforms, the main difference, the main pins, communication protocols, and some debugging bugs. So while you come to lab, you can take a Arduino or EST. You can first bring an LED, and you can use the Wi-Fi mode. Like I have explained, right? There are two modes: station and access point mode. So you can use that and try it to bring an LED. You can host a web server in that. You can toggle some switch to do some tasks like an LED. So like you can do whatever you like. So um, like we'll be soon doing some great projects. I hope so. And these are some resources I recommend you to learn. Arduino and Expressive. In these sites, you can get the pin diagrams of the Arduino and ESP32 and ESP8266. And in websites like Instructables and Random Nerd Tutorials, you can get to know how to set up your Arduino IDE for using this, and you will be having a lot of tutorials. Like if you want to set up something in your laptop, like for dual booting or for setting up a Raspberry Pi, you can have lots of tutorials in two sites. Okay, so concluding the session for now. So do you guys have any doubts? You can ask now. So are there any doubts? So if not, can you all put some reaction? So okay, fine. I think everyone is all right. So thank you for the session. See you soon, guys. Thank you.
Okay, yes. Bye, guys.